In this video, which is the second in the series of videos that we will have about using the Linux command line interface or the bash shell, we're going to follow up on some of the stuff that we discussed in the last video. One thing that I did not mention to you last time that certainly is very important is that the shell, and this is true of many shells, not just the bash shell, is case sensitive, meaning it matters whether you type in commands in uppercase or lowercase. Let me demonstrate that for you. Last time we learned about the ls command, which gives us a listing of the files. So let me execute an ls command here now, and you'll see I have a list of files that are present in the system. However, I typed ls in lowercase. If, on the other hand, I type ls as a capital L, capital S, it won't work. The shell is case sensitive. It matters whether you type something in lowercase or uppercase. There will be times when we type things in uppercase, but most Linux and Unix commands in general are named with lowercase. Now, those commands may be a program that sits on the disk of the system that is being executed, and that is the case with ls, or it may be a command like history, which is built into the shell itself. So you need to be careful about whether you're typing uppercase or lowercase, and you want to be careful about whether or not you hit the caps lock key accidentally, which may mess things up for you. Okay, now let's go back and talk about some other things. Let me do an ls again, and you can see I have 5 files sitting here that are present in the working directory. And remember, last time we also introduced the -L flag or option to the ls command, which gives me a long form listing of them. Now, we can create some more files here. And one easy way to do that, we introduced last time, was the touch command. So let's suppose I want to create a file named file2.txt, indicating perhaps that is going to be a text file. If I say touch file2.txt, and then I execute the ls-l command again. An easy way for me to do that, remember, is I can use the up or down arrow keys to cycle back through the previous commands that I have just executed, or I can use Control P to cycle backwards and Control N to cycle forwards. So let's go back. I'll hit Control N twice, and that will take me back to ls-l, which I'll execute again. You can see that now I have a new file that wasn't there before, file2.txt, which I'm just highlighting with my cursor here. That is a file that is presently empty. When I created that file with the touch command by executing the command, let me go back and show you the command, that command right there, it created a file, but it's empty. So touch can create an empty file for you where that file doesn't exist. Touch does something else. Touch also can update the modification time of a file. What do I mean by that? Well, let's look at one of my other files here, for example. The file hello_world.cpp. And I'm using an underscore in a file name, remember, because I don't want to use a white space in the name of the file. Hello_world.cpp is a C++ source code file. It's going to hold the C++ program statements for a program which we will very shortly write called Hello World. What's in the file really doesn't matter. Here, when I did the long form listing, right here in the text I'm highlighting right now, that indicates the time of modification of that file, last modification of that file. And that was today, July 15th at 16:13, that is 4:13 p.m., according to the clock on my computer. Okay, now if I say touch and then give that file name as an argument, hello world.cpp, like this, let me do the ls-l command again. Now, look at this. The modification time went from 16:13 up here. Now it's listed as 16:33, right? So touch can also update modification times of files, and there's occasionally times when you may want to use that. Okay. Let's recap a couple of other things we talked about last time. We introduced commands like cp for copying files, MV for moving or renaming files, and RM for deleting files. Let's suppose I want to delete this file, file2.txt. I can do that using the rm command. I can say rm file2.txt. I'll execute that. And you notice, unlike last time, this didn't prompt me when I deleted it. And that will be how RM behaves when you initially use RM. I'm going to set it up, so I'm going to teach you how to set it up so that you can always be prompted. And this is the default behavior of the RM command. It will delete things without giving you any feedback on it, provided that there's been no problem. If I try to delete a file, like let's say rm file3.txt, which does not exist in this working directory, it will tell me that I can't remove this because there's no such file or directory. And that makes sense. But when things go positively, the command will usually execute without telling you anything. Now, one thing it is important to understand is this is unlike a Windows desktop or a Apple OS X desktop, where when you drag things into the trash can, you can later retrieve them if you decide you don't want to delete it. Once I have deleted a file here, it is gone. There is no recovery possible on that. And so that's something you need to make very sure of, that you want to delete that file. Now, let me create that file again, file2.txt. I'll just cycle back here and execute the touch command again. And I'll do an ls, and sure enough, the file is there. Let's suppose I want to be prompted when I delete it. Well, one thing you can do in order to enable that is you can say rm-i. And the -i is a flag to the rm command. It means inquire. Basically, check with me to make sure that I'm going to do this, because rm is a command that could drastically change your life here if you delete something that's very, very important. So let's give it the argument of the file name. I'm sorry, not touch, file2.txt. And now it's actually prompting me. I can just say Y or yes to this, or if I say anything other than Y or S, it won't delete it. All right, but let me say Y, and I'll do an ls command, and sure enough, the file is now gone. All right, so you want to make sure that that's going to happen, and that's a good way to use RM right now. I'm going to show you later how to create something called an alias to make sure your RM command always does that, even if you don't give it the -i option. Okay. One last thing I want to cover in this video is how to look at what's inside one of these files. We have this list of files here. Suppose I want to see the contents of this file, hello_world.cpp. There are two commands that we can use to do this on Linux and Unix systems. One is called cat, and it stands for catenate. That is to display the contents of a file. So if I say cat hello world.cpp, right, it displays the contents of that file. And here it is right here. I'll highlight it here so you can see exactly what the contents of that file were. It's right there. That's what's contained inside that file. It is a plain text file that happens to contain C++ statements that basically create this program, Hello World. We'll talk more about this later, all right, when we get to discussing C++ in this course. We can also use another command called the more command to do the same thing. Hello world.cpp. In the more command, I also basically mistyped there. Obviously, typing here basically is very important. All right, so let's try this again. And it does pretty much the same thing as the cat command. In this case, it displays the contents of that file. So why do we have two different commands that do the same thing? Well, it depends on what's in the file and how much material is in the file. All right, let's take a look at that with a different file. I have a bunch of files listed here, and I have this one over here called Poisson_SOR.F90. It's a Fortran 90 source code file that contains a Poisson solver. Let's use cat on that. We'll say cat Poisson SOR.F90, right? When I do that, a whole lot of material scrolled by very quickly. I can drag my scroll bar up here and I can see there was quite a lot of material, all went by very quickly, all right? Hundreds and hundreds of lines of code, all right? Suppose I wanted to see that in a more leisurely fashion, say a page at a time. That's what more does, right? let me use the more command on Poisson SOR.F90 here, right? And again, I did that by basically just going back one command using the up arrow or the control P, and basically just using the arrow keys or basically control B to move back through the line, and I could edit that line by using the delete key and type in something new. So I didn't have to do a whole lot of typing to create this command. All right, let's execute more now and see what happens on that file. When I say more, it pages through the file one page at a time. Right? Notice that I'm seeing from the beginning of the file here a bunch of lines of text, and down at the bottom there is this sort of more with this dash 5%. It tells me I'm 5% of the way through the file. If I want to see the next page, the next screen full of the file, I just hit the space bar and it shows me another page of text, and I hit the space bar again and it shows me the next page of text. And so it's a nicer way to see a longer file is to use the more command. You might say, well, what if you want to back up? I can hit the B key and it will back up for me, right? So the more command is very useful for longer files, and the cat's very useful for shorter files, right? The cat will basically display everything. The cat is actually sometimes useful on longer files too. We'll learn about why that is later. So I can space through here. If I get tired and I want to quit, I can type Q and I quit, and I'm back to the command prompt here again. Okay. One last thing that I want to tell you, all right? You might think that you can use cat on all files or more on all files, and that's not true. Let me do an ls command here. As I said before, these tags that we put on files like .f08 or .pdf can serve as a useful indicator as to what type of file that is, all right? .cpp tells me, for example, this is most likely a C++ file. It doesn't have to be, right? Someone could have named a file something .cpp that had nothing to do with C++. But some files basically are not text files. In this case, hello world cpp, hello world.f08, lecture6.pdf and Poisson_SOR.F90 are all text files. They can be read with the cat or the more command, right? Hello world, on the other hand, in this case is a binary file. It is an executable version of this hello world program that I have here in hello world.cpp. If I try to use cat on that, let's try it. Hello world, right? Oh, I mistyped world. If I try to do that, I'll get something that looks like this. It's essentially gibberish to you. And that's because that particular file is a binary file. It contains instructions in machine code that the CPU of the system can execute. So we can't look at it with these, what's in it with these cat commands or the more commands. The same thing will be true if I try to use more on it, right? It will not be able to display what's in there. In fact, more is nicer. It tells me that it's not a text file. So beware of this when you try to use cat or more on files, that it will only work if the file contains plain text statements. So we'll stop for now and we'll continue this in part 3, which will be coming up soon.